We have some vectors here written in terms of components, and we want to find the magnitude and direction of each. Notice that they are different types of vectors. We've got what looks like a displacement here based on the units, meters, meters. Here's a velocity vector, meters per second. Oh, here's an acceleration, meters per second squared. You can tell by the unit what kind of vector it's going to be. Here's another displacement. So although these are different quantities, we will find the magnitude and direction of each in the same way. We'll follow the same procedure. Okay, we'll be using plenty of trig along the way. Remember your trig stuff. We're going to start off each time by drawing a little diagram. Look at our components and figure out what quadrant of the Cartesian plane we're in. Positive x component, positive y component. Okay, so we're in the top right quadrant. Let's draw a little set of coordinate axes, x and y, and we're going to go 2.5 in the x direction, 6.3 in the y direction. So our vector is going to look something like that. 2.5 this way, 2.5 in the x direction, and then 6.3 in the y direction. I know I'm going to be closer to the y-axis because this x component is smaller than the y component. All right, and that's A. We want to find the magnitude of A. That's the length of the hypotenuse here. And we want to find an angle. Generally, we pick the angle that's smallest, the one that's closest to an axis. So this angle here is smaller than this angle here. So we'll find this one to the y-axis. First, the magnitude is pretty easy. We'll use good old Pythagorean theorem here. So we know that the magnitude of A, denoted by putting absolute value signs around A, is equal to the x component squared plus the y component squared. Square rooted. And that comes out to 6.8 meters. Meters here because it's meters here and here on each component. Now we need the angle. We usually use tangent to get the angle if we know the two components. So we'll say that tangent of that angle is opposite over adjacent, 2.5 over 6.3. So that means that the angle theta is equal to the arctan of 2.5 over 6.3, which is going to come out to about 22 degrees. So we can write our final answer as the vector A is equal to 6.8 meters. That's the magnitude part. Now the direction part, at an angle of 22 degrees to the right of the positive y-axis. That's what we describe this direction. This is the positive y-axis. We're 22 degrees to the right of it. Okay, there's our result. Pause the video, and I want you guys to work out 2, 3, and 4 on your own. I'll show you the answers in a moment. Okay, ready? Here they are. Let me point out a few things. Notice that when you have a negative component here in number 2, when you take the tangent of that angle, you don't have to include the negative on that component. In this ratio, you don't need the negatives to figure out the value of that angle. But you do need to know how to describe that angle. This is going to be below the x-axis. This angle here is above the negative x-axis. That's the negative x-axis. We're above the negative x-axis. Here, this angle is to the left of the negative y-axis. That's negative y. We're to the left of that. Okay, next set of exercises. Let's go the other way. We're going to take these 4 vectors, given in terms of magnitude and direction, and we're going to break them into components. Once again, these are different types of quantities. That's an acceleration, that's a displacement, there's a velocity, but it doesn't matter. The procedure will be the same for each kind. Just make sure you put the right units on them in the end. Let's do the first one together. You guys will do 2, 3, and 4. Okay, 29 meters at an angle of 36 degrees west of north. You need to be able to know how to interpret a direction like this, west of north. What does that mean? Okay, if we have north-south, east-west, usually the x-axis is like our east-west axis. Y-axis is usually like our north-south axis. So if we are an angle to the north of east, that would be an angle like this here, above the positive x-axis. Another example, an angle north of west, that would be this angle here, sort of above the negative x-axis. Here we're going to the east from north. East of north means to the east from north. Down here we are going to the east from south. East of south means to the east from south. So study this picture so you understand what we mean when we say something like south of west. It'll be an angle here. Okay, we are west of north. So back on this picture, west of north, that'll be over here. You have to draw yourself a little picture. Draw a set of axes and put your vector on it. X-axis, y-axis. We're west of north, so we know we're up in this quadrant over here. And it's 29 meters, 36 degrees west of north. So 45 degrees would be that way, so we're a little less than that. Somewhere around there. Here we are, 29 meters at an angle of 36 degrees to the west from north. Drawing your right triangle. Okay, now we can label the sides. This is the y component, this leg of the triangle, and this is our x component, b sub x, the leg of the triangle parallel to the x-axis. All right, well, let's solve for each of those. We'll be using trig. We'll start by taking the sine of this angle, then the cosine of that angle. So sine of 36 degrees, that is opposite over hypotenuse, bx over 29, which means that bx equals, it's going to be 29 times sine 36, but we have to decide on the sign. Is this going to be a positive component or negative component? Well, we see that we're pointing more or less in the negative x direction. This x component is negative. You have to throw that negative sign on there. So negative 29 times sine 36 degrees. That's going to give us about negative 17 meters. Now we'll do cosine 36 degrees. That's adjacent over hypotenuse. That's by over 29. So by is going to be equal to, and now decide positive or negative, this y component. Well, we're pointing more or less in the positive y direction here. So that is a positive 29 times cosine 36 degrees, which is about 23 meters. Okay, we've got our two components, so we can write our answer. B in component form is negative 17 meters in the x direction, negative 17, then plus 23 in the y direction. I'm going to go ahead and pause the video. You can work out numbers 2, 3, and 4. Ready? Here are the results.